Welcome to Santa in the summer. I know it's almost 90 degrees out, but we have holiday spirit in here. I'm here to talk about Google Santa, give an introduction and overview. I learned about this tool about a year ago. I thought it was a fantastic tool and have made a lot of use of it. So I hope to share what I've learned and see if I can answer any of your questions about it. First, a little about me. My name is Todd Houle. I've been a Mac admin for over 25 years now. Most of my time has been in higher education arena. Responsible for a few areas within our group: software packaging, QA testing, deployment, as well as all Mac OS services. All right, so today we're going to talk about Google Santa. This is mostly a command line tool, so we will be using the terminal. Well, at least I'll be showing terminal output here. Not a whole lot of screenshots, not much GUI mouse work going on, so I'll just have output from terminal. Now, in order to use Google Santa, familiarity with terminal would certainly be helpful, but not required. If you've opened it, if you've typed a few commands, that's plenty good enough. The log files can be pretty extensive and valuable, so knowing how to use grep, awk, tail, all those sorts of commands will certainly be valuable as well. All right, so let's get into it. What is it? It's a whitelist blacklist tool. Naughty and nice. Now you see where the name comes from. It makes decisions whether to allow or deny an application from launching. So known malware can be prevented from opening. This is different than something like Jamf, which has a kill process if found option through its blacklist. I think they call it restricted software. In that case, the application is already started and then it's killed. Sometimes that can be pretty quick, but yet nevertheless there is potentially a delay. This is a kernel extension that gets right in the middle of the execution and can prevent a program from launching. It's managed from a command line tool. Also, rules can come from a sync server. We'll be talking about both of those things. Developed by the guys over at Google, and they were nice enough to release it open source. If you're looking for support on the tool, the Mac admin Slack channel Santa is a great resource. The developers often hang out there. If you scroll up, you're going to see mostly my questions, a lot of it, as I prepped for all this. But they're a great group of guys. Now, what is it not? So while this can prevent applications from launching, I do want to say there are definitely ways to bypass it. The commonly mentioned one is to take a malicious executable, wrap it up in a library, and then add that library to a known good whitelisted application. And then you can get your malicious tool to run. This is more designed for the person who says, I need Flash Player, and they just Google something, get a randomware site, and download it. This is going to prevent them from running known malware. It is not an absolute security blanket on your machines. This is one more tool in your arsenal to prevent problems in your environment. By the way, you guys are welcome to interrupt at any time, ask questions. If something's not clear, something is too clear, let me know. Kevin up front has the catch box we'll pass around, so feel free to interrupt at any time. All right, where to get it? You can get Santa from the GitHub page listed right here. Also on that page is a link to the documentation. Which is very extensive. It's very it's aimed at programmers almost, but there is also some useful info on configuring the tool in there. Now I will say, if you want to compile the tool yourself, you will need to sign the kernel extension. By default, if you have an Apple developer account and have a signing cert from Apple, that does not include the entitlement to sign a kernel extension. That requires special permissions from Apple. I was in Thomas Reed's talk yesterday. He said it took his company about 6 months to get that entitlement on their certificate. So Apple does not give that out easily, and for good reason. If you have a kernel extension, you've got a lot more power over the machine. So Apple really wants to make sure that that's held to a higher standard, whereas a developer certificate most anyone can get. So even malware's got a valid signing cert. All it takes is $100 and an Apple developer account. All right, what's installed? Once you download it, you get a package. It installs the kernel extension, which I mentioned previously. Also a daemon that makes execution based on the rules. So the kernel extension will monitor to find out when an application has requested an execution, when it's requested to launch. The daemon will look at the rules which we've defined, which we're going to define, and then we'll either allow that execution to happen or not. There's a GUI application that comes up if an application has been denied a launch. There's a command line utility, santactl, to configure standalone rules, which we'll be using a little bit in here, and the configuration profile, which where we configure Santa. Santactl has only a few commands in it. Most of the configuration is done through a configuration profile. Does not use plist preferences or anything like that. I do want to say, because it's a kernel extension, you will need permission to launch it on the machine. So if you install it out to your fleet, if you just deploy this to every machine you've got, the end users will see this kernel extension blocked message, and they'll need to open security preferences and click allow. Now, if you're in a managed environment, I'm sure you're aware you can put out a config profile to allow that kernel extension to run and not give that prompt. But just want to remind you that that is one more step in your deployment. Now, as we go through this, I'm going to mention two different modes, the monitor mode and lockdown mode. As you can see here, the only difference is in unknown applications. If an application is whitelisted, as in it's allowed to run, it's going to be allowed to run regardless of the mode. Obviously, if an application is blacklisted, it's going to be denied launch regardless of the mode you're in. The difference is in the unknown application. If you don't create a rule, somebody downloads an application and BBEdit, and they want to run it. Should they be allowed to run that or not? In lockdown mode, they will not be allowed to run that until you give them permission for that application. In monitor mode, yes, that application will be allowed to launch. So these are obviously very different use cases. Lockdown mode is going to be more for controlled equipment. Perhaps the users don't have admin rights. Perhaps you've got some hardware attached to it, some research equipment attached to it. So the machine really should not be modified, or it should only run a certain tool. That's going to be your lockdown mode. Monitor mode is more like the machines you've got here in front of you. Let's just prevent the known malware. Monitor what's going on for these tools, but in general, we're going to let things run. And as you see, as we move forward, you're going to be able to monitor and see what applications are run. Now, I know there's a big wall of text here, so you don't have to read it all. This is the output of the fileinfo command. If you run santactl fileinfo on an application, you'll see the path to the executable binary, the SHA hash of that binary, the rule. Currently, I have this whitelisted as a certificate, and the signing chain. Now, the signing chain is going to be the certificate used to sign that application. In this case, item number 1 is the developer code 42 in this case. I randomly picked crash plan. That's what came up when I was writing this. So in this case, signing chain number 1 is code 42. Item number 2 is going to be Apple's intermediate cert, and item number 3 is Apple's root developer certificate. Not going to throw all that up on the screen. But I did want to show this big block of text because when we go forward, it's going to make a little more sense when we pull certain things out of this. So what we can use is the fileinfo command with the key flag to pull out a specific line. So here you can see fileinfo crash plan key, give me the SHA-256, the hash of that binary. So it shows only that result, so I don't have to get the whole big block of text. This is different from cert index 1, the key SHA-256. So in this case, on the second line here, I'm looking at the first signing cert and give me the SHA of the thumbprint of that cert. So to go back a page, you can see I've got there's the first SHA. This is of the binary itself, a hash of the binary. And this is, if I can point to it right, the hash of the fingerprint of the signing cert of that application. That is important when we go to create rules. I want to show that there's two different hashes here. And if you do signing chain 2 and 3, you're going to get a hash of each of the thumbprints of those certs as well. So back to this screen, you can see using the key flag, I can pull out just those 2 lines specifically. I can also do a key rule and see just what is the rule of this application. In this case, Firefox is whitelisted via the certificate. Once we create rules, that'll make a little more sense. The other thing we can do is put multiple keys together. Say, give me the path, give me the SHA, and give me the rule of a certain application. So in this case, I chose the host info command. You can just do it on a flat binary. It doesn't have to be, we used bundles previously in the example. So show just those 3 fields. Further, we can use the R recursive flag. So say, of the user bin directory, show me these 3 keys, path, SHA-256, and the rule. And it's going to go through, in this case, I've only got 2 listed. But the output from that command is going to give you those 3 fields for everything in user bin directory, because it is going recursive. So once you, this is how to navigate the tool a little bit, so that once you want to start writing a script to pull this info, see what's out there, get the SHAs in order to create rules, these are the commands we'll be using for that. All right, so speaking of creating rules, here's how we do it. In this case, I want to create a blacklist rule for my malware. So santactl rule blacklist, and the path is application malware. Now, what that's going to do is add a rule to Santa database where the, oh, sorry, the hat's got to go. I don't know how Santa does this. Oh, much better. So in this case, we create a blacklist rule for malware. Now, what this does is take the hash value of the binary that's launched from that application's malware. So malware, contents, Mac OS, malware, the binary in there, it takes the hash of that and creates a rule to blacklist it. The problem there is what happens when malware 1.1 comes out. It's been recompiled. It's got a new hash value. It's not going to be blocked anymore. It's only blocking that specific binary. So this is the cool part here. Fileinfo, I can get cert index 1, get the hash value of the malware app of cert index 1. Remember that SHA of the certificate, the thumbprint we talked about earlier? I can create, you can see line number 3, create a blacklist against the signing certificate that was used to sign malware.app. So in that case, any application created by that developer is going to be blocked, regardless of the version, regardless of the name, the hash value of the binary. We're blocking that signing cert. That's way more powerful. And of course, if you're in a lockdown mode and you want to allow an application, you can allow Microsoft Office. They're all signed, the Office suite are all signed with the same certificate, so I can pick the one for Microsoft Word, get cert index 1, get the hash value of that cert, and allow that to run. Then when a new version of that application comes out, it's allowed to run. You don't need to modify your rule set at all. Firefox, new version comes out, you don't need to modify your rules, it's automatically allowed. So by leveraging the signing cert, it's a lot more powerful. Yes, sir. Oh, okay, you got some. Yeah, so the location on the file system is not relevant because we're talking about the SHA value of the signing cert of the application. When we go a little bit further, I'm going to mention scope. You can actually whitelist and blacklist based on file location paths. For example, block the volumes directory so that nothing off a thumb drive can be launched. Whitelisted applications, if an application has been whitelisted aloud, I should have mentioned this earlier, thanks for the tangent comment. Caching. The Santa, when it looks up the rules database, caches the rules, so it's not constantly going to the database and slowing down application launches. These happen very quickly on a high priority thread, so it's all very quick. There is little to no impact by installing this tool on machines. Whitelisted applications are held in cache until a new rule comes which supersedes it. A blacklisted application is held in cache for 500 milliseconds. So if an application is in cache, you move it, the directory, move it to a whitelisted or blacklisted path. It's going to go to cache and not look at the path in that case. So, sorry, did that make sense at all? Yeah, it was good? All right, cool. Cool. I know it's early, it's the first session of the day. You guys are still a little bit tired out, huh? Feel free to interject at any time. Rule precedence, I mentioned this earlier. If you have a specific rule, it's going to take precedence over the least specific rule. So a binary based rule based on the hash of a binary is going to take precedence over a certificate based rule. So if I have a blacklist against all Microsoft Office programs, but I have a whitelist rule for Microsoft Word binary, that Word binary will be allowed to run. No other Office application would be allowed to run because the binary has precedence over a certificate rule. Further scope-based rule take precedence over that. So if I have a rule that says nothing is allowed from the temp directory to run, can't have any executables in temp, that would take effect only if there were no binary or certificate-based rules. I don't think things are supposed to launch from temp anyways. Maybe Adobe does it. If anyone does, Adobe does. Yeah. But if you want to prevent it, that's one way to do it. Then we can know what Adobe programs break. Further, besides just applications, there's a little bit of info you can pull out of files. Santa is not focused on the files that are open themselves. It's an application execution monitoring tool. So if it's, but we can pull some info out of files. In this case, I'm looking at TeamViewer.dmg, which was downloaded. And you can see it does have the, I have the file info, so that big block of text, but we're only pulling out a couple of keys, the download URL, refer URL, and the timestamp. So here you can see I downloaded TeamViewer. The refer URL tells me where I came from and what the link was. So clearly I clicked it on the TeamViewer homepage. It pulled it from somewhere in Germany. And you can see this happened towards the end of February at 2 in the morning. I don't know why I was doing TeamViewer at 2 in the morning. But here, there's the evidence that says I was. So you can get info about files as well. All right, this command, sorry if you can't read it, not terribly important, but I just want to mention the status command. So Santa control status gives a chunk of info about the application and how it's running. You can see in this case, if you can see it, sorry if you can't, but I'll just tell you. Yes, it's connected to the driver, which is the kernel extension. It's in monitor mode as opposed to lockdown mode. You can see what rules are. I have 2 certificate rules and no binary rules when I ran the status command. I have 13 events pending upload to a server, which we'll talk about servers shortly. But also it shows watchdog events. As I mentioned, Santa is very conscious of creating any user impact in terms of CPU load, memory usage. It's very minimal and tries to be as nice as it can. In all cases I've seen, I have not noticed an impact by installing this tool. It's possible that if you're doing some heavy compiling and you do comparisons before and after, I'm sure you can see some impact from it, but it's going to be a relatively modest case. Oh, so I talked about blocked applications. I really should mention, what does it look like to the user? This is what somebody's going to see on the screen. They're going to get a window that says the application's been blocked. I'll read the text here. It says, the following application has been blocked from executing because its trustworthiness cannot be determined. Application name, where is the application, some other information about it, the fingerprint and so forth. This next steps button down on the bottom is completely configurable. We'll be talking about config profile in a minute. That button, you can configure the name of it, whether it appears or not, the link that it goes to. In fact, I think you can have the SHA of the binary as part of the link for that button. So if you're blocking applications, you can have links to different pages so that people can know, why was this application blocked? Or perhaps you're going to have a link to some database where people can contact you about, why was this blocked, this should not be, so forth. But that's an infrastructure on the back end you would need to put together. However, the next steps button here does give you the flexibility to do that. Oh, by the way, I should also mention, Santa prevents you from shooting yourself in the foot. The Santa daemon, when you first install the application and start it up, there's already 2 rules. The first one prevents you, is a whitelist for the certificate that was used to sign the Santa daemon itself. So you cannot, Santa cannot block itself. That would create an infinite time loop that would break all of reality. It can also has a whitelist on the launch D. Whatever certificate has signed launch daemon, that is also whitelisted. That's going to prevent you from just breaking the OS itself. Yes, sir?
So you kind of answered that question. There's only 2 rules.
Can we, let's pass that box back there, sorry, so we can get everyone to hear you. At least everyone in TV land. I know everyone in the room can.
All right, so you sort of answered my question. When you first started up, there's only 2 rules. Is there a set of like curated rules somewhere of known bad stuff, or do you have to set it all up yourself?
Yeah, excellent question. That is always one of the first questions that comes up with this tool. Where is the virus definitions and the list of known malware? So Google does not publish, or actually most anyone does not publish, a list of SHAs of known malware. It's left as an exercise for yourself. However, you're not left totally in the dark. There are solutions. Your security team may have, from whatever source they have, be able to output a list of SHAs of known malware binaries. You can also integrate with VirusTotal, which we'll be talking about shortly. But by default, there is no list of overarching virus definitions that's maintained. All right, I want to mention this log file that's here as well. It's in var.db. You might go looking in var log. It's actually in db, var.db Santa. In there is where it keeps its local rules database and events database. I guess they put the log in there just to keep things together. So in there, interestingly enough, is an event for every application execution that happens on the machine. So every time there's an execute command, and this includes these little binary tools, tail, more, cat. If you're a Jamf user and you run a recon, you want to do system profiler, awk grep, each one of those is an execution of a binary. And that's going to create an entry in this log file. So you can see what is happening at what time on the machine. Further, disk appear and disk disappear entries are also created anytime a volume is mounted or unmounted, whether it's a DMG or a network share thumb drive. So you can see when a drive was connected and removed. Logs can get quite large. My machine at my office is a very, very busy machine with lots of things running on it. It's 20 megs a day on that machine. This laptop is used less, just home use and so forth. So that's merely 2 or 3 megs per day. However, that's obviously a lot of lines of data. So some way to go through that is certainly useful, whether you feed it into Splunk or just want to search it yourself with your greps and awk commands. Going through that log file is quite a bit. In fact, let's take a look at one of the entries in that log file now. Here you can see one line of what was in the log file. So let's see what happened on July 9th. Looks like 6:11 p.m. All right. There was, Santa D says there was an execution. The decision was to allow it. Reason unknown. So clearly I'm in monitor mode, not lockdown mode, because it's an unknown application launch. SHA-256 shows the hash of the binary that ran, and the cert SHA-256 is obviously the hash of the signing cert. In this case, I see the developer ID is Dropbox Inc. It shows me the process ID and the parent process ID. ID 1, that's going to be launch D. User ID is 501, username is Todd. Group ID 20, group staff. Mode M, that's going to be monitor mode. And the path to where was that binary when it launched? It was in users Todd library, Dropbox, Dropbox Mac update, Dropbox update. So you can see Dropbox looks to be trying to update itself. Arguments that were passed to the binary. So if I've got a binary, it shows what arguments were passed to it as well. So I can see, well, Dropbox was trying to update itself at that time. Let's take a look at a slightly different log entry. In this case, another execution. The decision was to allow it. Reason is based on the cert. So in this case, I've got a whitelisting rule on that certificate. SHA-256 is the binary. Again, the SHA of the certificate. What do we got? Process ID 5820. Parent process 5813. What is it? I'm excited. Oh, tail. User bin tail. Arguments tail-f var log system log. So in this case, I ran the tail command. You can see the parameter that was passed to that application. Parent process was probably terminal in this case. So this has obviously got some strong uses for forensics on these machines. What happened, what time, where, and when. In this case, here's a disappear command action. Volume name, I have a DMG path there as well, date and timestamp. So you can see a DMG was mounted at this time. And then did the DMG go away? Yes, it did. Dis2 slice 2. So by looking through these log files, you can really find out what happened on these machines. Now I didn't mention, we'll go through that after. Sorry. All right, mentioned the config profile a little bit earlier. This is where you really configure the tool with additional settings. I briefly mentioned the regex pattern for a scope. So instead of creating rules based on certificates and binaries, it does have the option to create these regex rules. So I can say anything in users directory is prohibited from launching. Don't allow any application in a user's path. Now, how you use these tools is really going to be unique to every environment. Whether that's appropriate to block something or not depends on where you are and what you're trying to do with that machine. As you probably know, but I'm going to mention it anyways, profiles can be installed through your MDM, the profiles command line utility, or double-click the mobile config. So if you're going to put a profile in to allow that kernel extension, and a profile to allow to configure some of these settings. Other settings in the config profile, I can say the client mode. Am I running in monitor mode or lockdown mode? Monitor mode is the default, obviously. The regex whitelist and blacklist are options that are in there. More info URL is a string URL to open when someone clicks the more info button, and that has some parameters down that are well documented on the GitHub page. I'm not going to go through the entire config profile and all the options right now. There's a lot in there, but I just want to give you a direction to go to look at this a little bit further, should you be so inclined. Text to show on the button, and sync-based URL is a pretty cool one. This is where to get the rules. Here's syncing up to a server. So instead of creating rules locally on the machine with the santactl tool, we can have rules come down from a server. So, all right, let's talk about that a little bit more. So servers, there's three major servers. Now, Santa itself is its own standalone tool. It does not have a server component. There's three main options for different servers to use. Moroz is a it's a basic server written in Golang. Very simple tool, also very simple to use and standalone tool. I like it. You can set it up in about 2 minutes and have your server working. In fact, I'm going to talk about that one in a little bit, just run through how to set that one up because it is quite easy to get working. Upvote is also by Google. Cool thing about this one, a couple of cool things about Upvote is, first, it uses crowdsourcing, so people can vote, in essence, on whether a application should be allowed or blocked. If they get a warning, they can say, yes, this is trustworthy, allow it. If a binary gets enough votes, it's whitelisted. If people have questions about it, the reputation of that executable goes down. So it's kind of self-policing to some extent. Obviously, you have some control over it. The other thing is integration with VirusTotal. You guys know VirusTotal? You use that tool? Show of hands? Only a couple people. All right. Check out that website. You can upload a binary, an application to VirusTotal, and they're going to give you a reputation on that tool from multiple sources, I believe, and say whether this is malicious or not. You can also just take the SHA value, the hash of a binary, pass that up to VirusTotal, and it can give you the reputation of that binary. In fact, there's API interfaces. People have written many tools to just take, for example, run a Python script. It can run through your machine, upload the SHA to VirusTotal, and tell you whether it's potentially malicious or not. So Upvote also has that integration in it. Because of this, now it uses Google App Engine. It's got a local server, integration with VirusTotal. It's definitely much more complex to set up. It's definitely a bit more legwork, but if you're looking at a long-term implementation of this tool, it might be valuable enough to make it worth it for you. Zentral is another tool which is available. Zentral has, in fact, let me run through these a little bit. All right, we'll go back. Zentral has, is an aggregator of multiple sources of data. So it can take input from multiple directions and give you more of an overarching picture of your environment. So server events I mentioned a few times. I don't know if we saw when I was comparing monitor and lockdown mode, there were some asterisks next to unknown and blacklisted applications. If an application is blacklisted and someone tries to run it, an event is sent to the sync server. If an application is whitelisted and somebody launches it, nothing is sent to the server because we really don't care. That's allowed. We don't even want to know about it. It is recorded in the local log file, and you're welcome to pull that out of there if you're interested, but that is not sent to the server. An unknown application launch is also sent to the server as an event. You might want to know about that so you can look at what is it people are running. Should something be whitelisted or blacklisted, depending on what it is. here I am repeating myself, talking about the servers. Let's talk about Moroz a little bit in a little more detail. I like this tool because it is very easy to set up. You can run your own server in about 5 minutes and have it working. So if you want to play with it on if you want to play with Santa on a group of machines and have a sync server, this is definitely a great way to start. Written by Victor, I'm not going to say his last name. Very helpful guy. He's also on Slack on the Santa channel and is very helpful. He's answered a bunch of questions I've thrown at him about his tool. All right, so the events directory. So let's go through Moroz here. Pull it down, there's the URL to get it from. You can pull down a pre-compiled under the releases or build it yourself, as it's a simple Go app. I think it's about 2 commands to build it yourself. Once you've got it, here's the directory structure. I threw it into op Moroz because that's where I felt like putting it on my Linux machine. So this is the command to start it, opt Moroz, and this is all technically one line. It's multiple lines here for legibility on screen. The event directory is where does it store the events. I mentioned that a launch of a unknown application or blacklisted application generates an event that's sent to the server. Here's where events are stored. Configs, obviously, in the config directory. We'll talk about what the configuration file looks like in just a moment. It does require the use of a certificate. So you're going to have your cert and key available to the server. Do you guys have your own CA server? Yeah, you can generate a certificate? I'm seeing a lot of yes heads. Excellent. Okay, cool. If you don't, you are welcome to do a self-signed certificate. You can Google make self-signed certificate, and it's going to give you an OpenSSL command. You'll then need to take that certificate, not the key, take the certificate and trust that on each of your client machines if that's what you wanted to do. But hopefully you can create a real CA certificate that's trusted in your environment and use that. All right, so the config file, what does it look like? The config directory is a TOML, which is a format which may be familiar to you. It has a global file, which applies to all machines. Then it takes the UUID of each machine. When the client reaches out to sync, it sends up its UUID identifier. So you can have a set of rules just for that machine. Anything in the machine-specific rule file will technically replace what's in the global. So if you have a machine, if your global says you're in lockdown mode, but you have a machine you can put in monitor mode, so it applies just to that one. All right, here's what the file looks like. In this case, I've got the global file. This could just as easily be the uuid.toml file. Client mode is monitor in this case. The regex are commented out. We could remove those comments and have a blacklist everything in temp, whitelist everything in users. You guys know regex. You can get pretty crazy with that line if you wanted to. I don't use regex. My brain just does not expand that far. It's a tough one. A couple of settings for Moroz. I won't go into what those are doing right now, but down below is important. This is the rules block. These 5 lines you're going to repeat for every whitelist, blacklist rule that you want to make. It can either be a certificate rule or binary rule. It can be either whitelist or blacklist. The SHA-256 hash value is going to apply either to the certificate hash or the binary hash, depending on whether it's a certificate or binary rule. Remember, you get those with your fileinfo command. Use your key SHA-256 to get that hash value to make that. And a custom message. In this case, this is a whitelist. There's not really going to be a message, but I want to know what that rule is for, so I'm just going to make a note to myself that's Firefox, and I'm allowing it because we all love Firefox, right? Well, apparently in this case we do. And then you're going to repeat that rule block for every rule that you want to make. Now, the events directory. I mentioned launches of unknown applications or blacklisted applications. So in this event directory is the SHA value. It creates a directory with the SHA value of the binary that's been executed. So if this binary exists on multiple machines, you're going to have one directory that has one directory for that binary. Inside of there is the UUID of each machine that has run that binary. So you can see who has run it. And then, further, is a timestamp.json file of when that was run. That JSON file is going to contain the info on line number 2. What was the decision, executing user, all kinds of info about it. Who ran it, who was logged in when that binary ran. So not just the executing user, but you can see who else was logged in at the time. Process ID, parent process, and so forth. Lots of info in there. Now, so these are all individual files that it's creating. I think JSON is just directly what Santa sends up, and Moroz is just taking it and putting it into this directory structure for us. I think what I did at one point was I just wrote a shell script to run through these and generate whitelist rules based on some of this output that was in there. So these files are not terribly large, so it will create a new file for each instance of an unknown or blacklisted application. Directory is not going to grow terribly huge. It won't grow terribly huge too quickly, even with a large use space, because they are pretty small files. So that's Moroz. Let's mention Zentral. Open source tool. It's great for taking a bunch of data from different sources, putting it all together as an aggregation to give you an inventory and some control over your machine. You can see, for example, here's a screenshot of one of the screens you can get of Santa info within it. In this case, these lines, which I know they're tiny, is just these all say allow. This is the application that has been run, the executable, with some of the parameters, date, timestamp, so you can see what is running when on these machines. Upvote I mentioned a little bit earlier. I'll go through mention it again. Santa, the other thing Upvote does is if you guys are familiar with Bit9, Carbon Black, Parity, I think it's got several other names. I can't keep up. Upvote works with that as well, so Windows users can have the same Upvote functionality on their machines. This is a screenshot of the Upvote interface shown to users. You can see these buttons on the bottom say, what does it say? Vote to whitelist, or the bottom button, flag as possible malware. And there's info about the binary shown on the screen right above, so that people can see whether they should allow it or not. So if hopefully you trust your users in this case, they download something, they know what it is. Hopefully they're trustworthy enough to say it should be run. If not, yeah. All right, there we go. There's the end of that. Let's take some questions. Yes. Oh yeah, box. Yeah, I got to. Nice.
Good throw. You said this runs as a kernel extension?
Yes.
And those are deprecated in Catalina, as the Santa community talked about how they're going to move to system extensions past Catalina?
I have not been in on those discussions. I am aware that kernel extensions are going away. I'm sure they are as well. What direction they're going, I'm not quite sure. While this is a GitHub project, it's out on GitHub, it is a closed project. The developers are limited to the people at Google. They're using this internally, I think, on their machines. So the development is within that community at the time, even though they're sharing their tool with us.
Right.
So unfortunately, I've not heard what the solution's going to be, but I know this is a very active project, so I do not expect it to suddenly go away with Catalina.
Good to know. Thanks.
All right. All right, I guess everything's been answered that well, or did I just leave everyone confused? Or no answer? All right, well, I hope I answered everything well enough for you. All right, thank you very much, everyone.